Okay, today I'm going to show you how to use something called the area model to add fractions. So the area model is basically a manipulative that you can draw on your sheet of paper to add fractions. I know you guys all know the general rule for adding fractions. So when adding fractions, you simply have to get a common denominator. Once you have a common denominator, whatever you did to your denominator, you do your numerator, and then you go ahead and you add up the numerators, leaving the denominator the same. So the rule is pretty easy. So why use the area model? Well, the area model helps to make it more visual, and when it's visual, you're able to see what you're doing rather than just using a rule, because like I've taught you guys, sometimes just knowing the rule doesn't help. It's actually being able to see how you get there. So today I'm going to show you how to get there. So here's a fraction. I'm going to show you how to use the area model to solve this fraction. So the first thing you need to do is, for the first fraction, the denominator would be the floors. And the denominator of your second fraction is going to be the number of rooms. And so I'm going to show you how to draw the area model. So the number of floors, so you think of an apartment building or a building. So you have the number of floors. So we said the building has 2 floors. Okay? And then it has 4 rooms on each floor. So we split our building to have 4 rooms on each floor. You notice how much easier this is because nothing has to be the exact same size. Okay, so we've got 2 floors and we've got 4 rooms on each floor. So then you go ahead and you start coloring in your floors. So the first fraction says that there are 1/2 of the building. 1/2 of the building is occupied. So we're going to go ahead and occupy 1/2 of the building. Then we say that the second fraction says 1/4 of the building is occupied. So we're going to go ahead and occupy 1/4 of the building. But the thing is that 2 occupants cannot be in the same room. So you notice here that there are 2 occupants in the same room. So 2 occupants cannot be in the same room. So what we do is we go ahead and we take that occupant out of that room. We're going to add that occupant into a room of their own. Okay? So now you go ahead and you have your fractions in the apartments. And so now you count how many rooms you have, and the number of rooms will determine your denominator. So your denominator here, you can take a look, and your denominator is going to be 8. And how many rooms are colored in? So you go ahead and you count the number of rooms colored in, and you'll see there is 4 on the top floor and 2 on the bottom floor, so 4 and 5 and 6. So 6/8 is your final fraction. Now this fraction can be simplified, and so we know that they both can be simplified by being divided into 2, and so we know that our fraction is 3/4. Now let's verify using the rules that we know to see if this is the correct answer. So let's go back to the original fraction. So original fraction was 1/2 plus 1/4. You need to make your denominators the same. In order to make these denominators the same, we say we're going to turn the denominator. So we find a common factor. A common multiple, and the common multiple between 4 and 2 is 4. So we say we're going to multiply this denominator by 2. Whatever I do to the bottom, I do to the top. So my new fraction looks like this. Okay, and so again, then you go ahead and you add your top fractions and you leave your bottom fraction, the denominator, the same. So your numerator gets added and your denominator stays the same, and you notice that your answers are exactly the same. Again, using the area model, drawing it out, versus actually using the rule. So let's try the second fraction again. So like I told you before, and I want you to try this as I'm doing it as well, that way you can see how good you get at it. So the bottom, the denominator of the first fraction again is the floors. And again, you don't need to label it like this every time, I'm just doing this to show you. And the denominator of the second fraction is the number of rooms. So now I'm going to start drawing up my building. So I know that my building, my apartment building now has to have 6 floors. And so I go ahead and I draw a building in with 6 floors. I'm just going to count that. 1, 2, 3, 4, 5, and 6. Yes, perfect. 6 floors. And each floor has 2 bedrooms. So I just split it into 2 segments right there. So I take another color. I'm just going to grab another color. And so my first fraction says 2/6 of the building is occupied. So again, if 2/6 of the building is occupied, so 2 parts of it is occupied. And then my second fraction says 1/2 of my building is occupied. And okay, so I'm going to start drawing it in. So 1/2 of my building is occupied. And remember I told you that your tenants don't like to share apartments. They don't like to live in the same apartment. So these two cannot be in the same apartment. So we're going to give our circles their own rooms. So we kind of scratch them out of there. Okay, so now there is your area model drawn out. Now again, like I said before, your denominator is determined by the number of rooms. Okay, so the number of rooms in this building is 12, so 2 times 6 we know is 12, and the number of occupied rooms is 10. So your true fraction, your fraction answer is 10 over 12. Again, we can go ahead and reduce that fraction. And again, simply by dividing by 2, I can reduce that fraction, and my answer is 5 over 6. Now again, use the traditional method you already know, and verify. So again, let's verify here. I say, what's my common, my lowest common multiple? And I say, okay, what's my common multiple? I know that if I have to find a common multiple, I can say that I know that in the 2 times tables there is a 6, and so I simply take my 2 and I say 2 times 3 is going to give me 6. Anything I do to the denominator, I do to my numerator. So again, my new fractions become 2 over 6 plus 3 over 6. And I go ahead and I add them up. Again, my denominator remains the same. 3 plus 2 is 5. And again, you'll notice that my answer, using the method that you know of finding the common denominator versus using the area model, is exactly the same. So I'm going to do one more example with you, and then I'm going to give you a question to try on your own. So this example, you take a look at your first fraction and think about how many floors are going to be. So I look at it and I say, my denominator is 7, so I know my apartment building is going to have 7 floors. Okay, so let's count that out. 1, 2, 3, 4, 5, and I think that's 7. 1, 2, 3, 4, 5, 6, 7, perfect. And again, each floor has 3 rooms, so I split it into thirds. So there's my apartment building. So now let's go ahead and start filling in the rooms with tenants. So 3/7 of my building is filled. So I start at the top, and that's 1/3. 1/7, 2/7, and 3/7 of my building is occupied. Then I go to my very next fraction. It says 2/3 of the building is occupied. So I'm going to go ahead and give it 2/3. So that's so far 1/3 of my building is occupied. 2/3 of my building is occupied. And I remember my rule, and my rule says that 2 tenants cannot share a room. So I need to reorganize these 6 tenants over here. So there's 6 tenants that are sharing a room here, and we need to put these 6 tenants in their own rooms. So I take these 6 tenants and I start filling them here. 1, 2, 3, 4. Oh my goodness, we ran out of rooms. So we ran out of rooms. That means I have 2 tenants left over. 2 have no rooms. Okay, and so I know that that's going to be my remainder or my leftover. So how do I write this fraction? Your whole building is occupied. That means you have 1 whole. 2 tenants were homeless, so 2 tenants will now become my number that is left over, or my remainder, and altogether there were 21 rooms in this building. Okay, so that's my answer for this fraction. And again, let's try it using the method that you know, and that is the finding the common denominator. So I go up to my addition question at the very top again, and I say, what is the common denominator between 7 and 3? And I think about it, the only one that I can think of is 21, and so I go 7 times 3, and 3 times 3 up here, and again 3 times 7, and 2 times 7. So my new fraction is going to be 9 over 21 plus 14 over 21. I go ahead, I leave my fraction, my denominator exactly the same, and Okay, so I add my above fractions, and 9 plus 14. And so 9 plus 14 is going to be 23. And I look at this, and now this is an improper fraction. So I have to turn my improper fraction into a mixed fraction in order to make it work. So I take my denominator and I subtract my denominator from my numerator. So when I subtract 21 from 23, I end up with 1 whole with a remainder of 2, and my denominator remains the same. And if you notice, these two fractions are exactly the same again. So here's your last fraction. Before I actually give you this answer, I want you to go ahead and try it using the area model, as well as verify using what you know about adding fractions by finding a common denominator. So go ahead and try it, pause your video, and then come back to me. Okay, welcome back. And now, so if you look at the first fraction, it's 4 over 5. So I know that my apartment building, is going to have 5 floors. So I'm going to draw an apartment building and I put 5 floors into it. So I have 5 floors, and my each floor has 3 rooms. So I go ahead and I throw in 3 rooms there. So for the first fraction, I say 4/5 of my building is occupied. So let's go ahead and occupy 4/5 of my building. So that's 2/5, 3/5, and 4/5 of my building is occupied. Now I say 1/3 of my building is also occupied. So I go ahead and I start filling in 1/3. And remember what we said, we don't like to have occupants sharing rooms. So these 4 occupants need their own rooms. So if I fill them in, 1 and 2, so I'm left with 2 people who are roomless. Okay, so these people don't have any rooms. Okay, so if these people have no rooms, we know that that becomes my remainder. I filled a whole building, so I have 1 whole, and the number of apartments in this building, or rooms in this building, is 15. And so my answer is 1 whole and 2/15. Now again, using the method that I already know to be true, which is finding the common denominator, I'm going to go ahead and solve it that way as well. So I try to find the common multiple, the least common multiple between 3 and 5. And I know that there isn't really one, so I'm going to go ahead and, the common multiple is 15. And so I go ahead and I start filling it in. Whatever I do to the bottom, I do to the top. And let's go ahead and solve this. So I try to write out my new fractions, and so 4 times 3 is going to be 12 over 15 plus 5 over 15. And again, I leave my denominators exactly the same, they don't change, and 12 plus 5 is going to be 17. Now again, I know that I ended up with a improper fraction. I've got to change my improper fraction into a mixed fraction. So I see how many times can I subtract my denominator from my numerator. And so I know that when I subtract 15 from 17, I'm left with 1 whole because it subtracts in 1 time. And I'm left with 2 for my numerator, and my denominator remains the same. And you notice again, your numbers are exactly the same.